All right, now we're going to talk about the examples on page 2. So this is College Pre-Calc section 1.1, and it is the back of the sheet. So we'll start with example 3. It says, do these points make up a right triangle? If yes, verify. If no, say why. So when you hear the word verify in math, that means that you have to mathematically prove it. A mathematical proof is not graphing it and seeing if it looks like a right triangle to you. Verifying means you have to show with numbers and with proof that it is a right triangle. So we are going to verify a right triangle by kind of using the Pythagorean theorem backwards. So on the front, we had the Pythagorean theorem here, and if you have a right triangle, you get to use this formula. The converse of that is also true. If numbers fit into this formula, then it is a right triangle. If they don't fit in and it's not true, then it's not a right triangle. So if this side would be different than this side, it's not right. But if it does work out to be true, it is a right triangle. So I'll just write a little bit of that down. Side lengths need to work in the Pythagorean theorem. So what I'm going to do is get the side lengths. So number 1, step 1, I'm going to find the side lengths. And step 2, I'm going to plug into Pythagorean theorem. If it works, it is a right triangle. So I'm going to label these points. This will be A, B, and C, and I need to find side lengths AB, BC, AC. Once I have those 3 side lengths, I'll plug them into the Pythagorean theorem and I'll see if it works. So AB, the distance formula is x2 minus x1, so that's 4 minus 2 squared plus 0 minus 1 squared. 4 minus 2 is 2. 2 squared is 4. 0 minus 1 is negative 1. Negative 1 squared is 1. So this is square root of 5. I'm going to do that 2 more times. BC, so that would be 5 minus 4 squared plus 7 minus 0 squared. 5 minus 4 is 1. 1 squared is 1. 7 minus 0 is 7. 7 squared is 49. So it would be the square root of 50. Last is AC, so 5 minus 2 squared plus 7 minus 1 squared. 5 minus 2 is 3. 3 squared is 9. 7 minus 1 is 6. 6 squared is 36. And 9 plus 36 is 45. So I did not find decimal approximations for these. It's actually easier without. This is a leg. AB is a leg because it's the smallest side. And then this is the middle side, so this is also a leg. The longest side with the biggest number in the square root is going to be the hypotenuse. So I'm going to set it up, leg squared plus leg squared equals hypotenuse squared, and see if it works. Kind of running out of room here, but leg squared plus leg squared equals hypotenuse squared. So square root of 5 squared, the square root and the squared cancel, and it's 5. Square root and squared cancel, so it's 45, and then 50. 5 plus 45 is 50. That is a yes. It is a right triangle. So in order to verify, we had to find all 3 side lengths, plug them in, and they worked. If we ended up with something like, 49 equals 50, then it would have been no. it's not a right triangle because it doesn't work in the Pythagorean theorem. Let's move on to example 4. Find the midpoint. So midpoint is the middle of the 2 points. So it is the average of the x values and the average of the y values. So -5 and 9, I have to add those together and divide by 2. And I'll take the second values, -3 and 3, add those together and divide by 2. When you do this, order of operations will say you have to do what's in the parentheses first, and the parentheses, you could say, is around the top. You need to make sure that top is simplified first before you divide by 2. So -5 plus 9 is 4. 4 divided by 2 is 2. -3 plus 3 is 0. 0 divided by 2 is 0. So there's our midpoint. Last, we have to shift the triangle 3 units to the right, so we want to move it 3 units this way and 2 units up. And we want to find the vertices of the shifted triangle. So I have 3 points, -1, 2, 1, -4, and 2, 3. So in order to go 3 units to the right, 3 units to the right is going to move it along the x-axis 3 units. So the x-axis, we will find x coordinates as the first number. So if we want to move it to the right 3, we'll add 3, and we need to do that to every x coordinate, which is the first number. So I'm going to have -1 plus 3, 1 plus 3, and 2 plus 3. 2 units up would be moving it up this way, and that's a y value. So I'll have to add 2 to every y. So 2 plus 2, -4 plus 2, and 3 plus 2. So now I'll just do all of these little computations. -1 plus 3 is 2, 2 plus 2 is 4, it's 4, -2, and 5, 5. Those would be the vertices of my new shifted triangle.